Iskra and I'm associate professor at Aalborg University. I'm professor in operations and supply chain management, and I'm also project coordinator of the STREP project. I would like to start by noting that textile value chains are very complex, and because they are also very fragmented, both functionally and geographically. So if we look from a European perspective, for example, design and branding are often based in the Western and Northern Europe, while raw materials production, spinning, weaving, and are more dominant in southern and eastern parts of Europe, and also dominantly in Asia and parts of Mediterranean region. So on the other hand, the waste management infrastructures are still very much under development. For instance, textile waste collection is mainly done locally in different countries, and emerging sorting and recycling capacities are more centralized. So adding to this geographical complexity, we have on the top of that also the textile products, which are very complex, and this has direct impact on the recycling. A single product combines different fiber types, different blends, chemical treatments, coatings, accessories. And in addition to this, the information about these products and treatments is lost from the origin of all of this, and as the product moves further in the system. So this variety of complexity and lack of information significantly complicates the recycling processes at the product end of life. And this is precisely why a wide European consortium with diverse knowledge and competencies is essential. And our consortium actually reflects the high level of the real structure of the textile value chains. And beginning with the upstream side, we have Reutlingen University from Germany with expertise in textile innovation and design. Then we have Wonneberger Manufaktur, a German company that produces functional clothing. If we go further in the value chain, we have Nuritex, a Danish company, which is a leader in automated sorting of post-consumer textile waste, which in collaboration with Cabda from UK are working on improving the efficiency of the sorting and recycling processes. Then we have several research institutions and companies involved in innovating and developing the recycling processes themselves. Aalborg University contributes with expertise in enzymatic recycling, pyrolysis and solvolysis. Then Dissolva, a Danish company, focuses on chemical recycling solutions for polycotton blends and other complex textiles. Cure from Netherlands specializes in chemical recycling, particularly on polyester. T4E, also from Netherlands, supports pilot demonstrations to ensure scalability and industrial applicability. University of San Evangelista from the Czech Republic, they come with expertise in assessing the physical and mechanical properties of the recycled materials. CIRC, it's a Spanish research institute, provides expertise in real-time fiber length measurement as well as life cycle assessment. And last but not least, we have our digital infrastructure partners that enable traceability that ties everything together. And here we have a Zentrix Lab from Serbia that built a blockchain-based tracking system. and digital product passports, while Quantox from Germany develops circular data models and APIs that allow integration across the entire value chain. So bringing 13 organizations with so various competencies, it is a bit of challenge, but it's exactly what is needed if we want solutions to work in the real world. And then what helps that we work as a team, first of all, is that is the shared goal that we all have, which is to streamline the textile waste flows in order to achieve highest material recovery in a most efficient manner and with the lowest impact on the environment. Another enabler is that our partners have complementary skills. For example, the knowledge on recycling processes gives input and informs textile design on the recyclability of different blends. Another example is if we take the sorting phase or sorting experts. They are actually the link between the linear and the reverse flows, and they have really good knowledge on the end-of-use products, and they know how they should be recovered and in which flows. And these insights give input directly into our traceability experts that have to develop digital tools for tracking the products and then the fibers. And also my background in supply chain management gives me a natural curiosity about how different elements in a system interact and how they should be connected in the most efficient and effective way. So part of my role as technical coordinator, I spend in understanding partners' work and processes and translating what this means for other partners' work. And I do this through interviews. Sometimes I gather and clarify requirements from different partners and ensure that these are reflected appropriately in others' work. And then our project execution is structured around regular executive board meetings, which are supported by more detailed work package meetings. And these help us to balance specialized work with the needs of the overall project. And we can notice that the executive meetings are where collaboration needs really become clear and where joint actions are actually triggered. So on the other hand, they reflect or they highlight continuous progress in each work package. And by this, we build trust between the partners. And last but not least, their professionalism and engagement of each partner also plays a big role for creating a strong team spirit, I would say. Clarify, in the STREP project, we focus on fiber-to-fiber recycling, which is a process of turning used textiles back into high-quality fibers in order to make new products. And today, less than 1% of textiles are recycled worldwide. So there is a bit longer road ahead to get anywhere near to 100%. And one of the main reasons is the complexity of the textiles and the complexity of the reverse system. So not having information on the content of the products and their condition creates sources of inefficiencies, and this makes the recycled materials prices more expensive than the virgin ones. A lot of time and money is spent on manual pre-sorting to separate first the reusable items from recyclable ones. because we don't want to recycle good quality and good condition clothes. Then to remove accessories, to deal with separate double layer garments, and to handle contaminated products. And on the top of that, the recycling processes have strict requirements for the quality and composition of their feedstock. This puts high requirements on the automated sorting and the hardware separation process. And our project addresses these challenges by improving the efficiency and predictability across the system. First of all, we are improving traceability by using RFID sensors, blockchain, and digital product passport. So we know what each product contains and can deduce out of it also the condition of the product. And we expect that this will reduce the need for manual pre-sorting. We are also developing real-time fiber length measurement that will be integrated with the automated sorting process, and this will allow directing the right fibers to the right process. For example, sending long fibers directly to mechanical recycling, where their value can be actually preserved instead of over-processing these long fibers into some chemical process. And beyond that, we are also working on utilizing waste streams from different recycling processes. For instance, shorter fibers that cannot go into mechanical recycling can be processed enzymatically, and this otherwise this would have been turned into waste. So we will not hit 100% recycled used clothes overnight, but reducing unnecessary processing, improving recycling feedstock quality will increase the yield and will lower the costs. So this helps closing the gap between recycled and virgin materials and brings large-scale textile recycling closer to economical and also environmental viability. I think we are looking at different timelines depending on which technology we are talking about. Some of these methods are already quite close to the market, while others still require some further development. For mechanical recycling improvements and enhanced sorting technologies, we are talking about 3 to 4 years horizon. Nuritex, one of our partners, are already operating commercially, and the focus in STREP is about making them more efficient and to increase the sorting accuracy. The digital traceability infrastructure probably will be introduced gradually as well. Probably some leading brands might start implementing digital product passports within the next couple of years, and this will be especially stimulated by upcoming European regulations that will start mandating them from 2027-28. Chemical recycling technologies are on a slightly longer timeline. Our partners like Dissolva and Cure are working at pilot scale now, and I would estimate 5 to 7 years before consumers can widely purchase shirts that are clearly feature chemically recycled content from these specific processes. The main challenge aren't limited to the chemical process itself, but also include building the necessary infrastructure, establishing supply chains, reaching prices that make sense to the brands and to the consumers. However, I think having this direct connection between research on one hand and production companies on the other accelerates everything. So we get actually in the project immediate feedback on what works in practice and what doesn't. And the reality is that currently there might be a shirt or a pair of socks that contain some percentage of fiber-to-fiber recycled content processed through some of these methods that we work with now. But the real breakthrough will come when this becomes a default rather than exception, and when it is simply more economical and practical to use these recovered fibers than the virgin ones. And that's probably a 10-year horizon, but we are laying the groundwork in order to make this possible.